Hello, I'm Lesley Inker. I'm a nephrologist at Tufts Medical Center in Boston. I'm co-director of the Chronic Kidney Disease Epidemiology Collaboration, and I was asked to talk to you all today on lessons learned over 2 decades of CKD-EPI. Here are my disclosures. And I'm going to structure this talk into 3 sections. The first is the history of CKD-EPI from 2003 to 2018, focusing on our key results in collaborations and relationships with regulatory agencies. Then talk a little bit about our current phase, particularly related on governance, policies, scientific team, and output. And then finally on data acquisition, because asked to do a little bit of a deeper dive into some of the issues and challenges that we have with acquiring our randomized trials that we use in our analyses. So what was CKD-EPI? CKD-EPI was established by a collaborative agreement with the NIDDK in 2003 to address critical challenges in CKD epidemiology at the time. And here we have a picture of us at our first scientific advisory board meeting in Bethesda. Here I am, Andy Levy, who was the director of CKD-EPI and its initiation. Now we're co-directors. Tom Green, who you'll hear about, which has been our partner in looking at surrogate endpoints, which is the focus of what we'll talk about today. And Joe Koresh, who was our partner in all of this, but particularly related to GFR estimation, and some of our other colleagues at the time. So CKD-EPI had 2 big aims related to GFR estimation and change in urine protein as a surrogate endpoint. And of course, today we're talking mostly about, or all about, the surrogate endpoints and our work that has come up from this aim of CKD-EPI back there. And I just want to remind us of where we were in the CKD world just when CKD-EPI was established. So there were 2 things going on, I think, in the big questions. One was that there were no treatments for kidney disease. You've all seen this slide, which looks at the randomized trials in different medical disciplines. And here we are in kidney disease at this green line at the bottom. And we didn't even have an increase in the 80s as many other disciplines saw. The other thing that was happening was that the clinical practice guidelines for chronic kidney disease had just been published. And so on the basis of these issues, there was a desire from the NIDDK to say, how can we improve treatments for chronic kidney disease? Now we have a framework for understanding the disease, for the natural history, for earlier phase of the disease, but we have no treatments. And to address this question about treatments, we need to have surrogate endpoints, to have an endpoint that's viable in our long-lasting, slowly progressive disease. So one of the first things we did in starting this work on surrogacy was articulation of methods. And here I have a picture of Tom here, because he's been the leader in thinking about this and thinking about the methods and how we can do this so carefully throughout the years. I have pictured here in our timeline. I've colored here several of the years over more than a decade, because this work has improved and been refined over many years. And I'm going to show you some of that in our current work later on. But if we think about how we could validate a surrogate endpoint, we can think of 2 kinds of analyses. One is individual level associations between the change in the surrogate and the clinical endpoint. And we use Cox models to examine and change in a surrogate over a baseline period and subsequent development of kidney failure. And these are supportive, but not sufficient, as these associations can be confounded by predictors of surrogate and of the clinical endpoint. The second kind of evidence is our trial level associations. And these look at the association between the treatment effects on the surrogate and the treatment effects on the clinical endpoints. We've used Bayesian models that accounted for correlated errors amongst the surrogate and clinical endpoints, so we don't overcall the associations. And over the years, we've refined our work to include prediction intervals for use in future trials. Importantly, the effects are based on randomized comparisons, thus reducing the risk of bias from confounding that can confront both the surrogate and the clinical endpoint. Over the years, we've also added utility. when should we use a surrogate compared to the clinical endpoint? And particularly, we ask the question, does power improve with using a surrogate versus a clinical endpoint? And I'm going to show you just a little bit of this data. So now let's go and for a quick view of all of our work from 2003 to 2018, I'm going to show you the work that we've done to understand how urine protein or urine albumin can be used as a surrogate endpoint. So here we are again in 2003. We got the funding from CKD-EPI, and we started to identify our data, to acquire the data, to do the cleaning, analyses, method development. And then even while we were doing this, before we had results, the FDA said to us, this is a really important question. And came to Andy Levy and the National Kidney Foundation, and they said, can you put on a workshop to help us better understand use of urine protein as a surrogate? And the findings for that, we said, well, they could be helpful, but we didn't have any data to really support how they could be used in trials. We finally wrote our first paper on these analyses and these data, which took us a long time to put together. And we published it in AJKD in 2014. And we said we cannot rule out an association between the treatment effects on albuminuria, proteinuria, and the treatment effects on the clinical endpoints. We said, well, it could be used as a surrogate, but we don't have sufficient data. And we were actually correct to anticipate that it wasn't a negative finding, but it was just an insufficient data. And shortly thereafter, there were two more published, there were papers that were published, which suggested that in fact it was a more complicated question and we did need more data. One was published by Hiddo, Hirspink, and Jason, which showed a positive association. He used different analyses. He didn't use consider the correlation of the errors in the surrogate and the clinical endpoint. He used different time frames. So it wasn't an answer, but it was certainly supportive of that there was an ongoing question. And then subsequently, I published a positive association between the treatment effects of urine protein and the clinical endpoint in IgA, suggesting, again, that in certain circumstances, urine protein could be used as a surrogate. We then started doing a new literature search, expanding upon the work we had done before and identifying new studies that can improve the power so we could better address this question. And then, as probably many of you know, we put on a workshop supported by the National Kidney Foundation in collaboration with the FDA and the EMA, based on analysis, based on data, to provide a better answer related to could protein or albumin used as a surrogate. And I'm going to show you some of those results. Although our initial question was addressed in the form, can urine protein be used as a surrogate endpoint? Over these years in conversations with the FDA and the community, the questions have been asked as, can change in GFR be used as a surrogate? And I put up here as an intermediate endpoint because the change in GFR is really on the pathway to development of kidney failure. Again, here I have the same timeline we had before. We started with our first set of data, the same set of trials we used for analysis of urine protein we could use for initial analysis of GFR decline. And here the FDA came to the National Kidney Foundation in probably about 2010 saying, you know, we really want to know, can we use lesser decline in GFR? We use doubling of creatinine, which is a 50% decline in GFR. But can we use a 20%? Can we use a 30%? Can we use 40% decline in GFR? And so the National Kidney Foundation came to us and says, can you do analyses to address this question? And we did those analyses. And we had a series of papers published in JAMA and in AJKD that we were able to show that both a 30 and 40% decline in GFR were valid surrogates for end-stage kidney disease, kidney failure. And I think that these have been actually really helpful for advancing the field and understanding that there are viable endpoints that really could be used in the context of a reasonable timeline for a clinical trial. At the same time as we were publishing the results on urine albumin and understanding that question wasn't answered, we understood that the question of GFR slope was also not answered. And so as we were doing our new literature search to advance the magnitude of the trials that we could include to investigate surrogate albuminuria, proteinuria as a surrogate endpoint, we also address the question of whether GFR slope can be used as a surrogate endpoint, and we presented that too at the same March 2018 workshop. So here's a picture of all of us that the analytical teams, which were our SMART, and I'm going to show you in the next slide who they were. So picture the analytical team here, the NKF leadership, the FDA and the EMA, who we all together really worked hard to present an enormous amount of results to help to articulate endpoints for CKD trials. And the conference was chaired by Andy Levy and Ron Gansford. The analytical teams, there were 3 analytical teams. We had the cohorts to address the individual level associations, and this was led by Joe Korsh and Mark Grams at Hopkins under the CKD-PC Prognosis Consortium. And then we have trials. I led the group to look at the trial level associations at Tufts, and Tom Greed led a separate set of analyses looking at simulations, which allowed us to look at that utility question that I showed you earlier. And that was at Utah, where he's based. We had to address the question of change in albuminuria. We had 2 papers published in Lancet Diabetes Endocrinology, which looked at the individual level analyses and the treatment level associations. Here I have results from the treatment level associations, which we published. I'm going to just pause for a second and go through the structure of the slide, because I'm going to show you another one like it. So on the x-axis, we have the treatment effect and change in albuminuria. And on the y-axis, we have a treatment effect on the clinical endpoint. And this is in context of hazard ratios. So a low hazard ratio means a positive benefit on the treatment. And if you had a greater reduction in the treatment arm, you'd have a geometric mean ratio of albuminuria in this range. So these were where you have agreement on positive benefit on both the treatment effects on the albuminuria and the treatment effects on the clinical endpoint. We summarize this relationship looking at the strengths of the association using the slope and the R squared, looking at the R squared here. When we look overall, we were able to see a positive slope that if you had a stronger effect on albuminuria, it had a stronger effect on the clinical endpoint. And but it was reasonably moderate association of R squared of 0.47. If we restricted the patients to those who had a minimum baseline albumin level of greater than 30, then we saw a much stronger association. We were then able to apply this to say, because one thing to say, well, what happens in the past trials? Our goal here is to help investigators, to help sponsors apply to future trials. So what is the prediction for a future trial? So as I showed you, we have a trial level analysis in previous RCTs, which is a causal association between the treatment effects and surrogate and clinical endpoint. And this is what I just showed you in the previous slide. We said, okay, how do we apply it to a new trial? How can we convert the estimated treatment effects and surrogate to a probability of a clinical benefit on the clinical endpoint for new intervention, which is, of course, the question we're asking. So this is a complicated slide, but I think that it helps to understand what could be done. So for example, what we're showing here is if I had a 30% improvement in albuminuria in the treatment arm relative to the control arm, which is a estimated treatment effect of 0.7, if I had a large trial, I would expect to see a hazard ratio of 0.7 with confidence, the prediction intervals on that hazard ratio between 0.52 and 0.89. And so my positive predictive value for having a positive benefit in that trial would be 0.99. So it'd be very good. And even in a moderate trial, I actually have still a positive predictive value of 98%. So our main conclusion was that a 30% change, a 30% treatment effect of 30% would be very indicative of a positive benefit on the clinical endpoint in a future trial. For the We also looked at GFR slope, as I mentioned, and we had 3 back-to-back papers in JASN. I put here actually the front cover of the JASN article because it's very unusual that the JASN edition, because it's very unusual that clinical epidemiological work is on the front cover. And the editor thought that this was sufficient to warrant a cover. We actually worked together to get the color of the red dot right to match the JASN font. But the 3 back-to-back papers were, again, we had the individual level analysis that came out of the CKD-PC group led by Morgan Rams. We had the trial level work that we did here at Tufts. And then the 3rd paper now was the simulation data that Tom Green did. So let me show you some of those results. See, here we again have the, we have the trial level associations that I showed you, where we had the treatment effect on the slope with a surrogate on the X and the treatment effect on the clinical endpoint on the Y. And I apologize, but we do have a different direction where the benefit on both is now in the bottom right-hand corner instead of on the left-hand corner that I showed you earlier. But I'm showing you the total slope over 3 years or the chronic slope, which is the slope after 3 months. And you can see that for both, there's extremely strong relationships that the treatment effect on the slope, in the context of a trial, has a strong predictor on the clinical benefit seen within that trial too. R-squared is a 0.97 or 0.96 with reasonably tight confidence intervals, considering that there's only 50 dots here. What happens when we want to predict the next trial? And here again, I have the same framework that I showed you earlier. And so how do we convert this really tight association on the slope? What does that mean for a future trial? If I did a future trial and I only use GFR slope, what could have I expected to get on my clinical endpoint? So here, if we had a estimated effect on GFR slope of 0.75, and this is a mean difference between treatment arms. So what a difference that might be considered small in between treatment arms actually has a large effect on the probability of a clinical benefit, where we'd expect a hazard ratio of 0.69 with a 99% positive predictive value. This is the results from the simulations, and this is an extensive work. There's every dot here is a different analysis, where we have so the different colors represent the kinds of endpoints. So red is the chronic slope, purple is a 30% decline or development of kidney failure, orange is the total slope, and then blue is the 40% decline or kidney failure, and black is doubling of creatinine. And so he said, okay, well, what happens if you have a slow progressing population and you have a GFR, a mean GFR in the population, 67.5, and you have a 2-year slope? Then you could compare the number of people that you would require to enter into your trial using these different endpoints. And so you can see just in general, this is a really nice pattern that use of total slope instead of the clinical endpoint allows reduction in follow-up from 4.6 years to 2 years while improving efficiency by 17 to 64%. A sample size savings of 14% to 39%. And the relative gains of power for slope analysis increase when the baseline GFI is higher. So I know it's a lot of dots to go through, and please look through this paper carefully if this is relevant. But I think that these overall statements help to understand how these data could be used. The next, but it gets much more complicated when we have an acute effect. Here, it's similar plot in terms of it's grids by extent of follow-up in the columns. But here we have different kinds of factors. Here's the rate of progression with the 3 different rows. And then we have the magnitude of the acute effect. And my goal is not to go through to have any conclusions about the acute effect, but that just to say that acute effect is a critical consideration, a selection of total versus chronic slope versus a clinical endpoint. And so the key message to people involved in drug development or to sponsors, to investigators, just to understand your drug. And if you think there's an acute effect, and that should weigh into the consideration of which endpoint to subsequently do. So this is an amazing amount of work that Tom did in conjunction with his PhD and his group, Jin Ying, to provide these data for our community. They were a report in AJKD, and adjacent to their report were editorials from the FDA and the EMA supporting this work. And I'll just read out the orange highlighted sentences. These analyses provide an important foundation for further discussions with the nephrology community about GFR slope as an endpoint for registration trials from the FDA and from the EMA, that this work offers promising potential for a surrogate endpoint in the confirmatory phase of a specific clinical program. So not definitive, absolutely not. At the time, it would have been inappropriate. But I think that one of the, if you say to me, what was the highlight of this conference? And it was this amazing amount of work that we did, and really was a culmination of a year and a half of very intense investigations. But the culmination, I would say, is where we had the FDA and the EMA on a panel at the front talking to people in the audience, people who are really engaged in trying to find treatments for kidney disease and how to do it well. And it was on the basis of this conversation that we said, we can't just wait for somebody else to ask another question, to have another workshop. We need to have a way to have an ongoing conversation, an ongoing set of work and analyses that can continue this work to really help us bring treatments for patients with kidney disease. So now we are, this was 2018, now we're getting up closer. Oh, sorry, one more slide. So at this end of that, where we summarize the work now is if we had to say, what is our hierarchy of endpoints for kidney disease progression? Kidney failure, clearly, that's the clinical endpoint. I don't think anybody would question that. Closely behind is doubling serum creatinine, or a 50%, 57% GFR decline, and I think that's very well accepted. We put in the same bucket a 40% decline in GFR or a GFR slope reduction. And then below that is a GFR decline of 30% and ACR reduction of 30%. These were our opinions based on our totality of data. But I think it still is a reasonable way to think about it now where we are with the current evidence. But as I mentioned, the key message that came out of that work beyond the actual data and analyses is that we need to have an ongoing way to have these conversations. So what we did is we formalized all of the work that we've been doing from 2003. And we said, you know, in CKD-EPI is a research group with interest in GFR estimation and measurement and in clinical trials, but CKD-EPI-CT, or Clinical Trials Consortium, goal is to facilitate design and conduct of RCTs for CKD by developing evidence-based tools to rigorously evaluate trade-offs between alternative design strategies. We've developed a governance strategy that in some ways was existed before, but we more formalized it, whereas we at Tufts, the DCC, the Data Coordinating Center, we have a steering committee that's specific for CKD-EPI-CT, the clinical trials component, and that's a new factor, supported by the National Kidney Foundation. So the NKF is helping us to raise funds to support our ongoing work. At University of Utah, under the direction of Tom Green, we have our statistical center. And although I hadn't mentioned Hiddo except for his paper, he's been a partner with me in this work for a long time now. And he's at Groningen University with the goal to help recruit all of our trials. Here's all of us. Now we meet weekly by Zoom. We've probably been meeting weekly or bi-weekly since probably 2016, but it's become very consolidated now. And I put all of our degrees here because I want to say I'm actually the only nephrologist, and there's about 1, 2, 3, 4, 5 PhD level statisticians. And it's this amazing conversations where we try and think so hard about how to capture uncertainty in what we have to provide the most information we can to help define endpoints and trial design. We've, again, more formalized our organizational structure, publication and presentation ancillary studies policies. Now there's a lot of interest in CKD trials, as you all know, and people may, and sponsors may be interested in using some of our information or asking us to do analyses. And we wanted to formalize what we thought we could do and couldn't do. If you're interested, there on the Tufts Medical Center website, there is a CKD-EPI page, and we posted the protocols and policies, and you're welcome to look at it there. The other thing we did was actually better articulate the category results that we can share. We have primary analyses that can be used for internal discussion, including recordings of the webinars. And these are confidential, and they mean not to be shared outside of the consortium and not to be appropriate for presentation to regular agencies. We have QC'd specialized analyses, which are accessible on password-protected websites and can be used to regulatory agencies. And these are shared across the consortium, but not outside. And then ultimately, our goal is to have an online report that can be updated periodically. It takes actually a lot of resources to do that, so we're not quite there yet, but that's a foreseeable goal which we'd like to do. And then, of course, we have peer-reviewed publications, which are the ultimate goal. Importantly, for the first 3 items, we required a signed confidentiality agreement. I think this is one of the first times that this has been done, where we're actually asking the sponsors who are supporting our work, for collaborators who are sharing data with us, to sign this confidentiality agreement. We had to develop it internally at Tufts. We got it approved by the investigator colleagues, and then it could not be altered by any of the other people signing. And that is hard work, which I'm going to share a little bit more of when we actually do the data transfer. It's harder to put our foot down there, but here we have, and it's, we actually just finished this maybe about 4 months ago. So we'll see the impact, but it's, I think it's a great way to develop a way to have conversations within the people who are engaged in this space. We articulated 3 aims to define this work ongoing since past, say, 1.5 years. We wanted to evaluate surrogate endpoints with focus on methods and analyses of specific diseases and subgroups. We wanted to expand methods to combine GFR slope and short-term changes in albuminuria, and ultimately wanted to develop an adaptive design model for CKD progression trials. We've done a lot of new methods development, and I don't want to go through it all. I know I know the time is short, but for purpose of potential collaboration with PKD, or could be relevant for PKD, I wanted to focus on just 2 things, which is, I'll start at the bottom here, which is accounting for variation in trial level relationships across different types of kidney disease interventions. For any one disease, it's not going to be, or intervention, there's not going to be a lot of trials. We're not going to be powered sufficiently. The question we're asking is, can we take the power from all of our set of trials, but answer questions about a particular disease or intervention? And we think we can. And that's been work that's been done by Tom and some of his, and one of his PhD students who's just graduated. Willem has also looked at situating individual studies within the broader trial level relationships across CKD-EPI studies. And that's again to say, sorry for the siren, even in taped talks, you have to worry about the sirens. And to say, well, a disease may only have 2 trials, it's not even sufficient to a subgroup. But how do these trials compare to the overall set of studies? And I think that allows us to be more confident that even in selected subgroups or sets of diseases or trials, we can use the information from the overall set. Okay, now I'm going to turn to data acquisition, which I was asked to talk a little bit about. In preparation for this talk here, we took time to say, well, what are the steps that we've we do. You do all the work, but how do you put it together? We've listed 8 different steps. Defining inclusion criteria when you're doing a systematic search. Develop search terms for systematic review with systems that allow update periodically, and we're much more efficient at doing that than we were at the beginning, so we do that on an ongoing basis now. We have to request individual patient data from collaborators, and more recently via data sharing platform or external coding. We have to develop data use agreements, data transfer, data cleaning to ensure common variables across all data sets, compilation of combined data sets and analyses, and management collaborations. And I'm going to speak about just briefly 5 of these points. So first, request for individual data from collaborators is one of the most important things. It's hard to, I was pausing because everything is actually important. When I have a new coordinator come on, I talk about this extensively. This may be a big study, but behind that big study is a collaborator. And I treat that collaborator and I treat that relationship with a lot of respect. The emails are different. The relationships are different. And I it with a person or a patient, they're different. Each of these relationships are different. And I tell the new coordinator, I have to say, we have to go through all the emails that we've had over the years to understand what are the issues that have come up, how do we talk to each other, who are they, what are their concerns going to be, to make sure that we're in that conversation on an ongoing basis. But the thing that's come, I would say, in the past probably 3 years more than before, which there's now more data available through data sharing platforms. Theoretically, this makes it easier. It's not. It's actually much more complicated. I've listed here just some of the examples that we've at least used for the data sharing, but there's all sorts of issues that come up with all of them. And most of them are open access, but there's fees that can come up at certain times, and they can come up if you need ongoing use. Our goals are to do analyses over many years, to continue to ask questions, and that's not quite within their structure, so we're still working through some of those issues. The second thing we'll talk about is data use agreements. We had developed a standard agreement to avoid separate agreements with each study or sponsor, because as I alluded to earlier, every institution has their own particular concerns, even though the most simple of data use. We developed this way back in, let's say, 2015, 2016, where we're getting prepped for the 2018 conference. And we redid it lately with, new personnel at Tufts, and new personnel at Groningen and at Utah, but also because there are new concerns now that there weren't before. Using this base agreement, then we have to speak to all the other sponsors or collaborators who are donating data to us, and it has to be modified, and often can take several iterations, 3 to 12 months, although it's really, at the end of the day, it's very relatively simple issues, and the patenting of proprietary rights continue to be a challenge. And in spite of the fact that we will say there's going to be no instances where we see any patent issues. And so there's a lot of deep concerns about use of data, even under the auspices of now massive data sharing, which I find very interesting. And then data transfer has become more complicated to the need for de-identification, anonymization, and sometimes can take up to 12 months to actually get the data. Data cleaning. Challenges in data cleaning is consistent definitions, including key variables, censoring time, event definitions across studies. And we've really paid a lot of attention to this over the years. So for example, for those of you, particularly nephrologists, or have worked with urine protein or albumin, you know that there's multiple ways to measure it, either a spot urine sample or 24-hour, multiple different units. I've used urine protein and urine albumin interchangeably because it wasn't the point of getting at, to me, they are interchangeable in terms of a surrogate endpoint. But there's a lot of reasons of why the community is now moving to urine albumin. And so for our purpose, we've converted all to urine albumin. And if there's a question about this at the panel, we can certainly talk about that. We've also spent a lot of time although way back, and we use the same structure now, is to look at consistent administrative and censoring time. It's less of an issue now with these big trials, but at the beginning, we had trials of various different sorts, some of which had administrative censoring times and one did not. And for the sake of being sure we didn't have bias for endpoints that would just have been added on even after the trial itself was stopped, we had development, we derived a censoring time in several studies where a censoring time was not available. And then finally, just to comment on the clinical endpoint, it's defined in so many different ways. It's really very interesting. And actually, some of you may know that the ISN had a conference to define kidney failure for the purpose of trials. And I am completely in support because the way in which kidney failure is sent to us is just many, many different ways. And so this is something we continue to push back on to make sure that we're actually capturing dialysis or transplants opposed to a doubling of creatinine, because we're going to capture that separately, and we want to make sure we get those differently. This is an example of a flow chart that we'll put together to define how we identified studies through a systematic search and how we ultimately got to our final data set. This is actually from the 2018 conference. Our current one doesn't look quite as nice yet so far, but I put it up just to say we have to track all of the studies we excluded and why to make sure that we're doing this in a fair, systematic way. Once we get all the studies, we then need to make decisions on how we use them. Some studies have more than one treatment arm, multiple comparisons or factorial design, and then what our approach has been is to identify each treatment comparison to make it a two-way comparison. And so the ID&T study, for example, which had 3 arms, would have 2 different rows in our charts. We then had to also consider, what do we do with these small trials? And some of the small trials of the same disease and same interventions, we ultimately ended up pooling for some of our analyses. This is our current flow chart, which doesn't look quite as nice, but just to demonstrate that it's really an ongoing work how to continually to understand what's this data that we've identified as potentially coming in, what have we received, what we haven't received, and keep track of all of this and keep up the relationships and make sure that although processes are slow, that they are moving forward. 7, compilation of data sets and performing analyses. So we talked here about checking data, resolving any issues with the people who sent us data, the questions that we have about such things such as endpoints. We prepare for the data for analyses, we decide about the pooling, and then we perform all the results. And this is complicated. We have about 20 programs, some programs for the albuminuria analysis, about 25 for the GFR slope analyses, and then they're all put together. It could be up to about 100 files with the output to look at across groups, across subgroups. It's even after all the data comes in, it's an immense data management program how to look at all the outputs. And it's only then that we actually do the meta-analysis. And then so our simple figure that I showed you with all the dots of one trial is actually the culmination of this enormous amount of work. And I'm so grateful to my team here to have, and specifically Hossein Tigar, to manage all of this for all of the years. And here's finally, I just want to talk again about the importance of collaborators and of agreements to nurture and respect these relationships. Now in our newly inaugurated CKD-EPI, we're having bi-yearly webinars and going to start to soon have newsletters. We have progress reports, so I have to go to some of the data sources. We have to remember how to cite support from public platforms, which are different across different sites. We have to, although we may get data 3 years ago, we have to make sure we remember how a way to continue that when we do publish papers, maintain agreements, publication approval for some, financial support to acquire some of the studies. So there's an ongoing data management issues, even in the relationships and the agreements that we developed in all of these studies. So in conclusion, over the 2 decades, CKD-EPI has been able to make progress on evaluation of use of albuminuria and GFR as surrogate endpoints that I think have contributed to expansion of clinical trials in nephrology. Work is ongoing, is focused right now on understanding variation across subgroups and how to combine across endpoints. Complete data acquisition is critical to generalize results, but this is increasingly a challenge. Perseverance and respect for collaborators and needs are really critical. And finally, individual patient data are important to ensure similarity of variables across studies to minimize study effects. So thank you for your attention, and I look forward to speaking to you on the panel and I'll answer any questions.